All right, here we have another exponential growth problem. So we're going to be using our exponential growth equation. In a research experiment, a population of fruit flies is increasing according to the law of exponential growth. After 2 days, there are 100 flies, and after 4 days, there are 300 flies. How many flies will there be after 5 days? So what do we know? Okay, do we know how many flies there were at the beginning? No. Do I know what the growth rate is? No. Do I know my time? Yes, I actually do know this. I know that this is 5. What I'm solving for is the population after a certain amount of growth. Now this problem can become extremely complicated, or we can use what I'm going to just call a little trap door to make it a little simpler. And that is, even though this is supposed to represent the original amount of the population, I can still consider these two numbers to be, this is how much I had at one point, and this is how much I had after a certain period of growth. So again, do I know how many flies I started with? No. But I do know that there at one point were 100 flies in the population. After 2 days of growth, where I can call T2, there were 300 flies. How did I know that? After 2 days, there were 100 flies. 4 days, there were 300. Do the math. 2 days later, 2 days later, from 2 to 4, the population grew from 100 to 300. Okay, so is this the original amount? No, it is not. Okay, but I know that at one point there were 100, and then it grew to 300, and it took 2 days for that to happen. So what I'm getting from this equation is the growth rate, which is going to help me determine how many flies are in this population after 5 days. So if I go about solving this again, I want to isolate this exponential term. I'm going to divide by 100 on this side. I'm going to divide by 100 on this side. I end up with 3 equals e to the 2k. We're solving for k, so if we take the natural log of both sides, I'll have the natural log of 3 is equal to 2k times the natural log of e. We know that the natural log of e is 1, so they don't cancel, but it is multiplied by 2k. If I divide both sides here by 2, I'll get my growth rate, which is approximately, grab your calculators, 0.549. What am I doing with this? I'm using that. I'm setting up another equation where I have to find the population after 5 days. Now, here's the thing. I would put a 5 here if I knew what the amount of the population was at the very beginning. But I don't. And I'm saving myself the hassle of having to find that if I consider, well, I know there were 300 flies after 4 days. So instead of using a 5 for t, I could say, well, on the 4th day there were 300 flies. I know what this is going to be, and it took 1 day to get to that 5th day population. So here I can say 300e to the 0.549 power, that's k, times 1. And this is just a simple calculation. I'm not technically solving for anything here. Type that into your calculator, 300 e to the 0.549 power. We get 500 and let's call it 19 flies.